Hello everyone. It's nice that you're back to listen to the applications of Boyle's law. Really, it's interesting. And I would like to just remind you that Boyle's law said that the pressure is inversely related to volume. That's fine. That's right. Many of you have remembered it. That's great. And now we will see the first example is that of a syringe in which you can see that when you are trying to push the piston inside, the volume of the liquid is decreasing, so the pressure of the fluid increases, and so the fluid enters the body of the patient. And in a similar way, when you are just pulling off the syringe plunger, the volume increases, and this pulls the liquid from the bottle, injection bottle, or the patient. So we can see how the Boyle's law is acting in everyday life. And this yet another example of a bicycle pump, which we often use every day to just fill in the tires of the bicycle. When the handle of the pump is pushed down, the pressure inside the pump increases, and this makes the air to just escape into the tire because the volume is decreased. When you are just pushing the handle of the pump down, the pressure increases and the volume is decreased. So the air escapes out of the cycle pump. Isn't it the interesting example? Yes. Next is beautiful example of how our lungs functions, and the Boyle's law is very much involved in the lung functioning. See, the lung expands when we just breathe in. What happens? There is a expansion in the lungs, and this causes reduction in the pressure. So pressure inside the body is lesser than the pressure outside. So what happens? The volume of air just slips inside the body. This process is called as inhalation. So how the Boyle's law is operating? When the pressure is decreasing, the volume increases. When the volume increases, volume of the lungs increases, the pressure decreases. Either way. So how the Boyle's law operates? Hope you can understand. So how the Boyle's law operates? The pressure decreases because the volume increases. Why the volume increases? We are just expanding our lungs. Now, when we just breathe out, what happens? The lungs contracts. So, this increases the pressure from in the lungs, and so external pressure is lesser than that of the internal pressure. So, some of the air is expelled out. Okay. So, when the pressure increases, the volume decreases. So, this is the excellent example for how the Boyle's law operates in our lungs. So, once again, I would like to tell that when the lungs is expanding, its volume increases, so the pressure decreases, and the outside pressure is more than the inside pressure, and therefore to equalize the pressure, the air from outside gets inside, and this is called as inhalation. And when our lungs contracts, what happens? The inside pressure is more than that of the outside pressure, So some of the volume of the gas is expelled out, and that is called as exhalation. So it's an excellent example for Boyle's law. And now another beautiful example is where the Boyle's law is of very much importance is in the case of a sea diver. Sea divers are the people who go deep inside water to fetch the pearls or some valuable plants or something of that sort. These sea divers are professionally trained and they know how to act. What they do is, see, one thing we have to understand. Whenever we are going down the sea, the pressure is going to increase. So when the pressure increases, according to Boyle's law, what is going to happen? The volume is going to decrease. Yes. So the gas in the volume in the diver's body is going to decrease in its volume when the sea diver is going to go deep inside the sea. And now, when he is just going to come out very rapidly, he is going to come from the low pressure place to a high pressure place to a low pressure place. So what will happen? There is going to be a sudden decrease in pressure. So what happens? There should be the increase in volume of the gas. So when this happens suddenly, what will happen is all the joints, the gases in the joints will expand very rapidly. So what will happen? It causes the diver's body to bend. And so sometimes it can cause death also. So see how the Boyle's law is operating even in the diver's life. See, we have to understand and appreciate, right? The science, the gas laws are operating everywhere around us. We have to appreciate this. The divers know this. In fact, these divers may not know what the gas law is, but they will definitely know that they should not just be very fast when they are climbing up. So can you understand, students, how the Boyle's law is operating in the sea divers? So when the sea diver is going to just jump very fast from the deep sea to the surface, what will happen? Sudden decrease in pressure will happen, and this sudden decrease in pressure is going to increase the volume. So all the gases are going to increase in its volume. So what will happen? Suddenly there is going to be the collapse of the joints of the sea diver. Now, one question to all of you. Now, suppose cosmonauts are in space. We all know that these cosmonauts will be wearing the space suits. Let us imagine if this cosmonaut space suit is damaged. What will happen? Can Boyle's law help to give you the answer for this? Just think of. Okay. Yes, we will see in the next video. During the next video, we will see the answer for this questions. Till then, keep thinking, and in the next thing, this is an interesting information. This will give you a clue for the previous answer. There is a fish called as blobfish. This blobfish is living in a very deep sea. It's around 2000 to 4000 feet deep. So you know that in the deep sea, what happens? The pressure is very, very high. So what happens when suppose this blob ship is coming to the surface, what happens? This dies. Why? Because its body is so structured that it cannot withstand the low pressure. So, when the fish is traveling from a high pressure region to a low pressure region, the volume will increase, and so ultimately the blobfish will just become like this and it will die. So see how the Boyle's law operates in every walk of life. Suppose there are problems like this that is asked. See, for example, a gas has volume of this much and pressure of this much. The same gas, the pressure is increased to 1000. What will be the volume? So in this case, pressure and volume at one temperature is given. Pressure at another temperature is given. You can definitely find out the volume by using the Boyle's law, because PV is equal to constant and P1 V1 is equal to P2 V2. So this is how we have to work out the whole problem. Hope you all can note down the problem and work it out by yourself and check with the answer. Yes, we have come to the end of this video, in which I am just going to summarize whatever we have studied in the previous two videos on Boyle's law, which states that pressure is inversely related to volume, and ultimately we arrive at PV is equal to a constant. So in the next videos, we will see about the Charles and the Gay-Lussac's law. Till then, thank you.